Hello friends, welcome to ePathshala. Today we will discuss about formatted I/O in C++. In the previous module, we have seen standard input-output operations using cin and cout. Cin is the stream object of iStream class and cout is the stream object of output class. Cin is used to give the input from the standard input device keyboard and cout uses the standard output device, the screen. Today we will see about the formatting. Now what do we mean by formatting? In formatting we will see about how to specify the width to input or output the number of characters, specifying the alignment, whether we want left alignment, right alignment. We will also specify the precision of digits, number of digits after decimal point and so on. So let us start. In formatted I/O we will be covering the topics like what is formatting, what is the need of formatting, how to format using the stream member functions of iOS class and how to use the manipulators. We will also see how to check the errors and the possible errors. What is formatting? We have seen that during input output operations the numbers are getting converted and the strings are also getting converted as per the local layer. Now this conversion can also be formatted as per the specifications given by the user, and the specifications given by the users may be filled with the alignment, the format of the number, whether you want a number in hexadecimal, decimal or octal, maybe specifying the precision for floating point numbers, maybe specifying the padding characters for extra positions and so on and so forth. What is the need of formatting? Number of times we require to generate the reports, for example mark sheet, where all the heading and the corresponding data should be aligned properly. In bill, the items, their quantity, their price, all those things should be aligned properly. In passbook, the bank entries, stock price list, the calendar, all these things are using formatted output. See this example of generating the mark sheet. Let us first of all understand the guidelines for the alignment. Whenever we display the items with the labels and the value in the single line, we should use left alignment for the output items. Whenever we are using tabular format, in that case the column heading should be left aligned for strings and right aligned for numeric items. In the actual data, the numeric items should be right aligned and the strings should be left aligned. If the numbers are floating point or real numbers, then we should use fixed decimal point format, and the number of digits after decimal point should also be specified, and we should print the decimal point always whether it is required or not. Maybe for example the numbers 1, 2, 3 and we want to display it as 123.00. Now how to control this formatting? For that C++ provides 3 state variables: width, precision and fill, and it also provides one flag, formatting flag, which is of the type enum fmt flags containing all the bits, and individual bits we can set for different requirements. In C++ we can use formatting using iOS member functions as well as using manipulators. What are manipulators? Manipulators are a special type of non-member functions. That means they do not belong to any class. They are just like overloaded operators, insertion and extraction, and the main advantage of using manipulator is they return the reference to the stream of the calling object, and therefore we can use it in cascaded manner. We can also have our user defined manipulators, and C++ also provides the predefined manipulators, and we can use their short name also. So these are all the advantages of using manipulators. So let us see what we will study here in formatting. We will use the member function width to set the width and manipulator set w. To set the precision, we will use the member function precision and manipulator set precision. To specify the fill character, for filling extra spaces, we will use fill member function and we can use set fill manipulator. Similarly, to set the bits of a format flag, we can use SetF member function or we can use set iOS flags manipulator. To unset, we can use UnsetF member function and we can use reset iOS flags manipulator. In addition, we can use the flag function to get or set all the bits at a time of the flag, and there is no corresponding such manipulator. So let us see one by one. First of all, we will see width, fill width, specifying how many characters we want to use, how many positions we want to use for input or output of the data item. The default width is 0. It means that whatever is required should be used. We are not interested in specifying the width. Till now we have seen the standard I/O in the previous module. They are all using default formats. They are not taking the formats given by the user, and therefore till now whatever operations we have done, they are using default width 0. The syntax of using I/O as member function is we should specify the width as the argument and it returns the previous width as the return value. Obviously, it cannot be cascaded because it is not returning the reference to the calling object. In manipulator, it returns the reference to the calling object and therefore it can be used in cascaded manner. For example, cin greater than setw5 greater than str. So, the item str should be displayed using only 5 positions. In field width, whatever settings we specify, they are not permanent. That means after each use it is reset to 0, and therefore if we use like cout less than set4 less than 12 less than dash less than 45 and L. In this case, the output will be space 1 2 because 1 2 is to be displayed using 4 positions. Now, after that the width is reset to 0 again, and therefore item dash will be displayed just using single character as per the requirement, and 4 5 will also be displayed using the required width, that is only 2 positions, and therefore our output will be space 1 2 dash 4 5. If I want 4 5 also to be displayed using 4 positions, for example, then the width is to be specified again. Let us see this example. setw4 12 dash, again we say setw4 and then we say to output 45. So, it will display space 1 2 dash space 45. Now, the same thing using member function. Instead of setw we will be using width, and width is another thing is it is not returning reference to the calling object, therefore we cannot cascade it, and therefore we will have to use here in this case at least 4 such statements. We cannot write a single statement. Now, another thing is regarding what if the specified width is greater than or larger than the required one. In this case, if we are using it for output for O stream, the specified width is considered to be the minimum width to be used. That means if the width is smaller, then it will be ignored. For example, I say setw4, but the item to be displayed is 5 2 3 6 7 8. So, it requires 6 positions and the specified width is smaller. In this case, it ignores the width, but if the width is larger, then it will use the required one and the extra spaces will be filled with some specified character. By default, it is space, as we have seen before while displaying 1 2 with width 4, it displays space 1 2. For I stream, that means when we are taking the input, it is considered as the maximum to be used. So, if I specify 7, maximum 7 is to be used. After 7, the extraction should stop. But in case the invalid character appears before 7, for example, before the specified width, then that width is ignored. So, in a given example, when I say cin dot width 7 and cin greater than n, cin width 10, cin greater than str. For example, we have given the input 1 2 3 4, thank God. In that case, for n I have specified width 7, that means it should scan 7 characters. But after 1 2 3 4, it gets invalid character t for the numeric, and therefore even though I have specified width 7, it stops at t and the value extracted will be 1 2 3 4 in n. For str, we have specified width 10, that means it should scan maximum 10 characters. Now, here it will start from t, but the extracting will stop at space, because space is the terminating character when we use extraction, and therefore the str content will be just thank, even though we have specified width 10, it will extract only 5 characters. So, this is how width can be used. Now, let us see field character. Field character is actually used when we have some extra positions in the output. How to fill those positions? Usually when writing check, the check amount, if you have marked, is written with the leading asterisk. The extra spaces are given by asterisks. Such things we can achieve using field member function or SetField manipulator. The default is space character, as we have seen, and another difference as compared to width. Now, whatever settings we will be using, the settings are permanent. That means once it is set, unless and until we change it, it will remain in effect. I/O as field, the return is the previous field character, and we will specify as an argument what filling character we want to use. See this example, cout width 7, then we say fill character to be used is asterisk and I want to output 1, 2, 3, 4. If I want to output 1, 2, 3, 4, it will be displayed as star 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 1, 2, 3, 4. The same effect we can get using the manipulator. The only advantage is we can just use it in cascaded manner, that is all. Now precision. Precision we use to specify the number of significant digits to be considered in output, especially for floating point numbers. By default the precision is of 6 digits, again the setting is permanent. We can use the iOS member precision, like others it will also return the previous precision and use the current precision as whatever is specified in the argument. We can use the manipulator precision, set precision for the same thing. In this example, I have said cout.precision 5. So, it will consider only 5 significant digits. Now, see my item to be displayed is 1, 2, 3, 4.567. So, it has 7 digits, but only 5 significant will be displayed. So, the output will be 1, 2, 3, 4.6. Here you can mark that it does rounding. That means, if the precision is shorter or larger, then what will be the effect? As we have seen, if the precision is shorter, then it will do rounding after the decimal point. What if the precision is smaller for integral part? So, for example, I have said 1, 2, 3, 4.567, but I have set the precision of only 3 digits. Obviously, in such cases 1, 2, 3, 4 cannot be rounded, and instead it will use scientific format to display such items. When the precision is larger, it will be ignored and only the required precision will be used. Now, the fourth one, FormatStateFlag. In FormatStateFlag, it is consisting of different bits which can be set individually. As said, it is of the type enum, which is defined iOS class. It is of the type FMT flags defined in iOS. Now, some bits are grouped. For example, adjust field. The name of the group is adjust field and it has the 3 bits left, right and internal. Similarly, another group base field, it has 3 bits OCT, hex and DEC. The third group field is FloatField and it has 2 bits fixed and scientific. Other bits are not grouped, they are like skip, white space, bool alpha, show positive sign, show decimal point, show base of the number, uppercase, the base should be shown in uppercase and so forth. To specify these format flags, we need to use the scope resolution operator. So, we should use it as iOS : which is the scope resolution operator and fixed the actual bit. We can combine more than one flags also together. For example, I want to say that I want to use fixed point notation and I want to force showing the decimal point also. In that case, I will have to mention iOS fixed vertical bar, that is the OR operation, bitwise OR, iOS show point. Setting these bits can be used by using the function SetF, where we will specify the flags. SetF comes in 2 forms, SetF and the argument format flags, and SetF the argument format flag, and we also specify the group. In the second format, first of all it will reset all the bits of the group specified in the second argument, and then it will set the necessary bits as specified in the first argument. In the first flavor, it will just set the bits as per the argument, and the return type you can see is FMT flags. That means the previous flags will be returned as the value, the prior settings will be returned. See the example, cout.setf iOS : left, that means we want to left justify the items, and the second form we are using cout.setf iOS left and iOS adjust field. The second one is the group name of the bits. We can reset all these flags using UnsetF class member function. Here we are specifying the flag as the argument by which flags are to be reset, and again it returns the prior settings. We can use the flag function to set or get all the formatting flags at a time. In the single time we can set all the bits or get all the bits. The flag function returns the prior flags, prior settings, and if we pass it without arguments, obviously we are not specifying any flags, so it will simply reset to all 0. Now, how can we set or reset using manipulators? that means we are working on format flag. We can use set iOS flags to set the flags, and we can use reset iOS flags to reset the flags. Obviously, the argument is to be passed here, and the return value will be the reference to the calling object. So, we can again use it in cascaded fashion. Now, let us see the alignment. Horizontal alignment we are talking. The group name is adjust field, and the three flags as we have talked are left, right and internal. The right is the default value. By default all the items are right justified. We can specify the left alignment also. We can use the manipulator name also as left instead of saying set iOS flags iOS : left as seen in the example. How internal works? Internal, when we specify, it will leave the extra positions between the sign and the magnitude. This is how it differs. That means the sign is always in the left position, and thereafter it will do the alignment for the magnitude. Integers, when they are to be displayed or considered as an input in the given base. Here the base may be either octal or decimal or hexadecimal. To specify base, we use the group field base field, and the bits flags, dec, hex and OCT, oct. The manipulator name we can use DEC, hex and OCT. Now, with this we can also specify whether I want to display the base or not. To show the base, we should use iOS : ShowBase flag, and even we can specify whether the base is to be shown in uppercase or lowercase, especially in case of hexa. The base is shown as X, and if I want to show X in uppercase, I should specify uppercase. If I want to show X in lowercase, I should not specify uppercase. So, uppercase and ShowBase are the additional flag we can use with this type of data. Now, formatting real numbers. FloatField is the group name, and the two possible flags are fixed and scientific. Fixed is the default one, that means by default it will use fixed decimal point notation. If we specify scientific explicitly, then it will use scientific notation for the items. In addition to these flags, here we can use show decimal point. We can force to show the decimal point by using show point flag, and the corresponding short name in the manipulator is show point. For fixed and scientific also we have the short names fixed and scientific, easier to use. Now, in case we want to have, if we want to say fixed number of digits after decimal point to be shown, for example, I want to show only 2 digits after decimal point, and the decimal point also needs to be aligned, for example, as here it is given in the list. In that case, we will have to use two flags, fixed decimal point and show point, and we need to specify the precision also. By doing this, we can give the output of the numbers with fixed number of digits after decimal point. So, in this example, see, I have used fixed and show point setting the these two flags, and we have also specified the precision variable having value 2 here in my case. We can use the manipulator. Here I have used short name fixed and show point, and we have used the function set manipulator set precision specifying argument 2 for 2 digits after decimal point. User defined manipulator. Manipulators, as we have said in the advantages, they can be used in cascaded fashion, and the second advantage was that user can define their own manipulators. How user can define their own manipulators? To define their own manipulators, we should follow this specific coding structure where the return type is the reference to the stream, then manipulator name we will specify, and the parameter should again be the reference to the stream. So, as it can be seen, the header is very similar to overloading, extraction or insertion operators, and the return type in the function, body of the function, we should return whatever is the parameter, that means the reference to the stream. Let us take the example here of defining the user defined manipulator to print the dash line. So, every time I want to print the dash line, I will use just a dash as the manipulator name. So, for example, I will say cout less than dash. When I say this, actually it will call this overloaded operator, this manipulator dash here, and execute the body of the function. Now, here I have used it with cout. So, the return type is ostream ampersand sign, that means reference to the ostream. Dash is the name of the manipulator. In the header I am talking, and the argument which I have passed is ostream ampersand Pout. So, my object is of the type reference to the ostream. The body of the function says output width is 80, the justification is left, the fill character which is to be used is dash, and after that I want one space and endl. Then we say set fill the character. Now, here if you see, set fill is used to reset the character back. Otherwise, as we know, in set fill the setting is permanent, that means unless and until it is changed, it remains in effect. So, the following output also will consider dash as the field character, and that we do not want. So, we need to use here Pout set field space, where space is the default one. That means I am resetting my field character back to the default value. So, this is how we can use the manipulators. We can define our own manipulators and use them. Now, let us talk about the error occurring during input output operations. What if either input or output fails? For that, in C++, they have the stream state, the object of the type IO state, defined again in the iOS class. Actually, all these members are defined in the iOS base class, but iOS is derived from iOS base. That means they are available in iOS class also. We will talk here about 4 bits in the state, stream state. Good bit, when we say good bit, that means there is no error in the input output operations and all bits are set to 0. EOF bit will be set when it encounters end of file, when we are taking the input from the keyboard, maybe Control Z. When we then fail bit will be set whenever there are some logical errors while input or output operations. For example, I have said to read the number, but I have entered all characters which cannot be converted into number. Then in this case it will say fail. Sometimes it may be premature end of file, that means I am reading but end of file have already occurred. So, fail bit may be set during such type of cases. Bad bit will be set whenever not due to logical error but due to some hardware error, maybe the data is corrupted or lost. So, in this case stream is not okay, whereas in case of fail bit the stream is okay. Now, once this error bit is set, again it remains in effect, that means the permanent effect. So, if suppose end of file bit is set and I am trying to read another data, then also it will get end of file bit as set. So, it is better, it is the programmer's responsibility to check the bits, error bits, and again clear them before performing next input output operation. To check these error bits, either we can simply use those constants for the error bits in the if statement, or C++ provides some member functions also in the class, like not the overloaded operator, void star, good function, EOF function, bad function, fail function, and the return value are all self-explanatory as given in this table. We can use the RDState function to read the stream state, all the values of the stream state. It will return the value of the type IO state. Clear function can be used to clear all the flags. So, in today's session, we have seen what is formatting, what is the need of formatting, how to format using iOS member functions, using manipulators, how to see the errors. Especially in formatting, we have seen the horizontal alignment. We have also seen how to specify the precision, how to specify the width, how to specify the field character, and we have also specified different format flags. Especially formatting is controlled using 3 format variables: width, fill and precision, and 1 format flag variable. So, these are the 4 things we have used in controlling the format. In addition to this, we have seen the errors in IO stream and how the good bit, fail bit, bad bit, EOF bit are set, how to reset them, and we have also seen some functions which can be used to check this input output errors. I hope you all have understood it. It is easy to use, please practice it, and now we will see for the next module.